again on the same concept of digital, but taking it a bit, one step ahead, I can say. Do we have Harshada online?
Yes, ma'am.
Harshada? Yeah, quickly, Harshada, can you please take the screen? I'll answer.
Yes, ma'am.
Yeah. And Harshada is one of the students, one of my students. Harshada, Shubham. Then we have Nagusha sir.
Hitesh.
Yeah, she's sharing. Yes. Hitesh. Yeah, I was just checking whether she's able to share or not. We have Hitesh, Satyam, and Sankar. All these students, they were working with me on this particular lab. Yes, quickly, can we go ahead? So
yes, ma'am.
Yeah, I think it's 3:55. Yeah, she's trying to show you one more, that is digital logic design using gates. And
the first experiment.
I'll just explain. You can just click on design of multiplexer. So here, the aim has been suggested. The students will be able to select appropriate gates to build a multiplexer circuit, okay, to identify the role of a multiplexer circuit, and to design, construct, and verify the operation of a 2:1 multiplexer using basic logic gates. So these three things are as the outcomes that we're looking for when I'm designing the circuit. Yes, can we go ahead with it?
Yes, ma'am.
I think we can directly go to the simulator. People during the hands-on, they can go through the other things of the lab manual. Yes. So what has been done here is, scroll. There's a quiz initially, for this particular multiplexer. Yes. She has started the quiz. And there comes the first question: which basic logic gate will you choose on inputs of a 2:1 multiplexer? I'm trying to check whether the student has, knows the concept behind it. And then he's going to answer that question. Give a correct answer. She says AND gate and she submits that answer. Yes, that is correct. Hence, it's gone green. Go to the next question. Yes, the next question is about, which gate would be used to select line 2:1 multiplexer. Give the answer. You may give a correct answer because we have less time. Yes, check the answer and go to the next. Yes. Next question is about which basic gates would be used to choose the output of 2:1 multiplexer. The student is going to answer. So it's interactive, the screen is asking some questions to the student and the student is answering. It is not about MCQs. Let me tell you, it's not about MCQs. I'm trying to check whether he knows the concept behind it. Yes, can we go ahead? Right, just a minute. Look at it. It's given me a pop-up saying your score is 5. Why? Because on the first hit itself, I could give the correct answer. So the student is motivated. Yes, I have got a score of 5, right? And if he's going wrong, he'll get a score which is -1 each time. Yes, we can go ahead. So that he has completed the first level, he goes to the next one. Proceed to the next stage of the simulator. So you click on next stage. And now let us see whether he has understood the function table of the multiplexer. So here there's a question. What will be the value of the select inputs S2, S1, S0 to get orange juice? Yes, please click the answer. Click the answers. So if he has understood the function table, he'll be in a position. Bingo. She's given the right answer. So it gives a message saying bingo. So that's again a motivation. And it says, please read the next question. So these interactions happen and keep the student occupied, or you're engaging the student for all the throughout the experiment. The next question is about selecting the inputs for, again, red juice, for example. So she selects it for red. Red is 6. So it is 110 that she's going to enter. And yes, bingo, she's got it right. Otherwise, it's going to deduct the marks. Please read the next one. Yes. Now that was about the select lines. Now this question is in a different way. Here the value of S2, S1, S0 is given and he's got to answer. Select the juice. Yes. So if it is 0, 0, 0, it's violet. Yes, that's right. And then next question. Correct. I'm going a bit fast. Yeah. Okay. And here comes 2 questions for each type we are giving, and the student will be. So now we know, yes, the student is in the position to answer his scores, or even he is able to check that he's on the right path. Can we go ahead, Harshada? Yes. Now, let's look again at the function table, like the way that was done in a slightly different way, so that the understanding is made, so that he understands the concept. Let's go and make it more technical, showing the to table, the function table. Yes, you can complete that task. Harshada, please. So if enable bar, if it's not enabled, obviously output is going to be 0. And if it is 0, output is D0 and D1 and submit. So on the right-hand side, he has the mux representation. Look at the scorekeeper there. The scorekeeper is telling your question 1 has scored, you've got 5 marks for it. Yes, can we go ahead? Click the correct Boolean expression. I'm trying to check whether he's in a position to also identify the Boolean expression that is there. Yes. I'll ask her to give correct answers in this case because we have less time. Yes, we can go ahead. Proceed to the next step. Yes, that answer is also right. So has scored 515. So you can go to the next level now. We're trying to take the student step by step. So he should not look at the blank screen, what has to be done. Okay. So here we are guiding him. Yes, can we quickly take this experiment, Harshita? Yeah, she's trying to build a circuit. Again, you have a canvas over here, which is now available for the multiplexer. Now, this is not a generalized one. This is for the multiplexer. So that is going to verify the function table, which is he created in the earlier session. On the right-hand side, you have the function table, so that he or she is going to build the circuit and is going to verify. So isn't it a self-learning tool in this case? So the teachers can think about their subjects. And yes, she's used a Y connector out here. So whenever a single connection has to be made to multiple points, we can make use of this Y connector. Because when you code it, we need to take care of all these aspects. And each time you'll find on top of the screen, it's telling, select second connection is completed. It's guiding the student throughout. So you could also explain this in the online teaching also. You could show it this way or ask the students to do it, perform it, okay? And learn. Yes, you can simulate and show the results. Harshada? Yes, okay. So D0 is 1, output is 1 because she has enabled it. And now D1, yes, you have got to select it first, enable it. Yes, that D1 is 1, output is 1. So in this way, you could show it to the students, or you can ask the students to take up these labs. So these would be useful for both the fast learners as well as the slow learners because it's guiding throughout the session. Thank you, Harshada. Thank you for quickly doing that for me. Yeah.
Thank you, ma'am.
Students are very, very smart. They are very quick. They pick up so quickly. And let me share the feedback from my students that they have gone through this subject in second year. She is now in third year. So when she was in second year, she has developed this particular these labs with me. And she has also got a platinum certification for it at RC Banda. This entire team, I appreciate them. I really take this opportunity to appreciate the teamwork of the students, along with the faculty. And that's how we could come up with another lab. Just give me a second. And but our SENTC syllabus, if you look at it, we have the experiments based on, that are based on ICs, so the trend that we have taken is we started with small scale integration, SSICs, then we went to MSICs. Now MSICs, yeah, you'll find one more lab out here. Why I'm showing it? So that you know the complete package which is available. Just a second. Let me scroll. Electronics, logic design. Yeah, digital logic design. This is a final year project of IT students. I'll not demonstrate here, but I would like to show you the scenario in the simulator, so that you are aware. Yes, something type does this. I'll just wait for a second. Okay, so I'll straight away go to the simulator. Well, the experiment was about implementation of 8:1 mux using MSI ICs. If you look at the list of experiments, by the way, you'll find all these experiments, they are there as the first 4 experiments for your digital electronics syllabus. Okay, so faculty can outrightly use these labs, ask the students to use it. Why? Because it's going to help them to learn the subject very effectively, or you can deliver the contents very effectively. The videos and everything is provided. Now, this is a scenario where in colleges, if they have a digital trainer kit, they can use this particular way to demonstrate. Okay. If you directly give this particular trainer to the student to handle, you may feel there is nothing much in it. He just has to click on, the inputs, select the inputs, turn on the power supply, and set the values and check the output. This is what you may feel. Well, that's not the case. It's the teacher's skill, how he's going to deliver the content to the students. How did I go? I went with the first lab, and then the second, and then I came over here. That he knows what are the internal gates, how do they function, how I can use, in designing certain applications. Now let him use the ICs. Now the beauty of this experiment, I'll just show. I won't demonstrate the experiment. You can do it during the hands-on session. Is it also has a timing diagram out here? Okay, there's a timing diagram here. So if now the inputs are 111, it's a multiplexer. If I switch my input 7 as 1 after switching power supply on, the output is going to be 1. So let me capture this. I can capture the timing diagram. Can you see that? And if you are going to stop it, you're going to change the input and again, ask it to capture, and you'll get the timing. So the concept of timing diagrams also is given to the student. And while doing that, then you can tell them what is this propagation delay, from where does it come, and so on. How to relate what the content is on the virtual lab. It's really the skill of the teacher. And above that, here also the manual for each of these, each of these is provided. The data sheet, I may say, not the manual, the data sheets is also, you can also go and click and check the data sheets, and the student can, it's everything is available, the entire package is available. I think many more experiments are there. Integrated circuits lab is there. Then you have the network labs and so on. There are many labs, but since we are running out of time, with the permission of all the dignitaries out there, all my faculty colleagues who have been listening to all of us, and the only objective that we have in this entire workshop is we would like to share this virtual lab tool with you people, and you in turn, we wish share it with your students, and we make this learning happen, teaching learning happen in a very interactive and a playful way, I must say, in a playful way, so that students enjoy learning. Yeah, I just take this opportunity to thank everyone for going through this session with me, along with me, and keeping me motivated till the end of the 2 experiments or 3 experiments that have been demonstrated. Thank you so much. Meenal ma'am?